Hello everyone and welcome to Sally and Bytes. Today, I am here to teach, using Python libraries, Part 1, for the Class 12 students of Computer Science. In this video, we are going to learn Introduction of Modules, Package and Library, Module in Python, Importing Python Modules, Name Resolution, Module Aliasing with Practical Implementation. So, let's dive in and get started. Let's discuss about using Python libraries. Normally, a general library, you can see in the first picture, is a collection of books or is a room or place where many books are stored to be used later. Similarly, in the programming world, a library is a collection of precompiled codes that can be used later on in a program for some specific well-defined operations. Other than precompiled codes, a library may contain documentation, configuration data, message templates, classes, and values, etc. So, what are Python libraries? Python libraries are collections of precompiled code modules that offer specific functionalities. They simplify programming by providing ready-to-use code, saving developers from writing repetitive tasks, as we don't need to write the same code again and again for different programs. Python libraries play a very vital role in fields of machine learning, data science, data visualization, etc. Let's see the relation between module, package, and library in Python. Module. A module is a file containing Python code that can define functions, classes, and variables and statements with .py extension related to a particular task. A module allows us to organize our code by grouping related code, which makes the code easier to understand and use. Package. A package is a directory of Python modules. It is a namespace that contains multiple packages or modules. It is a directory which contains a special file $init_.py through which Python interpreter interprets it as a package. Library. A library refers to a collection of modules that together cater to specific needs or applications. For example, Math Library of Python caters to mathematical computations, NumPy library deals with scientific computing, etc. First, we can discuss about modules. A module is a single file containing Python code that defines variables, functions, and classes. Let me explain this with an example. If the content of a book is not indexed or categorized into individual chapters, the book will become boring and complicated. Hence, dividing the book into chapters makes it easy to understand. In the same way, Python modules are files which have a similar code. Thus, a module simplifies a Python code where classes, functions, and variables are defined. Now look at the second point. It serves as a way to organize code and make it reusable by allowing you to import its contents into other Python scripts. Modules can be small, containing just a few functions, or larger, encompassing several related functions and classes. Examples of modules in Python include math, random, and datetime. Look at the first box. How to create a module. To create a module, just save the code you want in a file with the file extension .py. Example, save this code in a file named mymodule.py. Def greeting of name, : print, hello, plus name. Now look at the right side box. How to use a module. Now we can use the module we just created by using the import statement. Example, import the module named mymodule and call the greeting function. Import mymodule. Mymodule.greeting of Sam. There are several built-in modules in Python, which you can import whenever you like. Advantages of Python modules. Code organization. Modules organize code into separate files for better project management. Group related functions and classes in a single module for improved readability. Code reusability. Write functions or classes once, reuse them in multiple parts of the project. Saves time and effort by avoiding redundant code. Namespace management. Modules create separate namespaces, preventing naming conflicts. Use the same names in different modules without issues. Modularity. Break code into smaller modules for easier development and maintenance. Work on individual components separately. Standard library. Python's extensive standard library provides pre-built modules for various tasks. Reduces the need for external dependencies and speeds up development. Platform independence. Python modules run on any platform supporting Python. Simplifies cross-platform development. Let's discuss about Python module names. A module name is the file name with the .py extension. When we have a file named empty.py, empty is the module name, the _name _ is a variable that holds the name of the module being referenced. Let's see this example. Import random. This line imports the random module from the Python standard library. After this line executes, you can use functions and classes from the random module in your code. In line 2, random.name . This line accesses the _name attribute of the random module. In Python, modules have several attributes, and _name is one of them. The _name attribute is a built-in variable that holds the name of the module as a string. Output of example 1 is random. The reason for this output is that the _name attribute of the random module is set to random. In other words, the value of random.name is the string random. Look at the second example, line 6. The _name attribute is particularly useful when you want to determine whether a Python script is being run as the main program or being imported as a module into another script. When a Python script is executed directly, its _name attribute is set to _main . If the script is imported as a module in another script, the _name attribute will be set to the name of the module, in this case, random. Look at the code of example 2. If you have the following code in a script called example.py and if you run example.py directly, Python example.py, it will print. Now look at the output. This script is being executed directly. This is some _ function in example.py will be printed. However, if you import example.py in another script, the if _name equals _main block will not be executed, and only the functions and classes defined in the module will be available for use. Key points of module names. A module's file name should end in .py. If the module's file name does not end with .py as the extension, we will not be able to import it into other programs. A module's name cannot be the same as the Python keyword. Naming a module as for, while, etc. would result in an error. The name of a module is stored inside a constant _name . Importing Python modules. In Python, importing modules is a way to bring the functionalities defined in one module, Python file, into another module or script, making them accessible for use. It allows you to reuse code, organize your codebase, and avoid redundancy. There are several ways to import Python modules. First point, using the import statement. The import statement is the most common way to import a module. It allows you to access all the functions, classes, and variables defined in the module. The syntax is import module _name. Example to generate a random integer between 1 and 10. Let's look at the code. In line 1 we import random module and printing the random integers between 1 and 10 in the second line. The output will be 10, next time 6, next time any random number between 1 and 10 and so on. To import multiple modules, it can be done as import module underscore name 1, module underscore name 2, and so on. To access particular methods from any module, the statement shall be module name.function name. Here, you have to note that, to use or access or invoke a function, we specify the module name and function name separated by a dot. This format is also known as dot notation. Second point is using the from import statement. The from import statement allows you to selectively import specific items, functions, classes, or variables from a module directly into your current namespace. The syntax is from module underscore name import item underscore name 1, item underscore name 2, and so on. Let's see an example. In line 1, from math. This specifies that we are importing functions from the math module. Import sqrt, pi. This imports the sqrt and pi functions from the math module directly into the current namespace. Now you can use these functions without referencing the math module. In line 2, sqrt, of 16, this calls the sqrt function that was imported from the math module. It takes the argument 16 and returns the square root of 16, which is 4.0. This directly accesses the pi constant from the math module. The value of pi is approximately 3.141592653589793. Third point. Using wildcard import, not recommended. You can use the star symbol wildcard to import all items from a module into the current calling namespace program. However, this practice is generally discouraged as it can lead to namespace pollution and make it harder to identify the source of functions or variables. The syntax is from module underscore name import star called wildcard. In this example, from math module the sign function is accessed. So sign of 0 is equal to 0.0. It is recommended to use explicit imports, import module or from module import item, to make your code more readable and avoid potential naming conflicts. Also, try to avoid wildcard imports from module import star to maintain a clean namespace and improve code maintainability. Note that, while importing using from keyword, do not refer to the module name when referring to the methods or functions. Let's see an example. In line 1, we import the pow and factorial functions from the math module using from math import pow, factorial. Then, in line 2, we use these functions to perform calculations. Pow of 2, 3. This calculates 2 raised to the power of 3, which is 8. In line 3, name error, from math we have imported factorial in the first line. So need not use math.factorial. Let's see some examples. Now look at the first code. Let's say we have a Python file called area.py which has a few functions in it for calculating the area of a circle, square and rectangle. Let's use those functions again in some other programs. Now look at the first code. We have created the area module, which is a user-created module, not from the Python library. However, this program uses the standard math module for using pi function that belongs to it. Now, we shall call these modules in another program named math1.py. You can see in the second code below. Note: always remember that the module area.py should be in the same default root folder where math1.py also resides. In the second code below, the import statement gives access to all attributes and methods present in the module. Methods in a module are accessed using syntax module.method function. When we run this program, the submodules, namely circle_area, square_area, and rectangle_area, shall be called from module area using the statements area.circle_area, area.square_area, area.rectangle_area. They shall generate the output as shown on the right side of the screen. Retrieving objects from a module. There is another function dir, which, when applied to a module, gives you the names of all that is defined inside the module. Let's see an example. When you pass an object as an argument to dir, it lists the attributes and methods available for that object. Here, area is passed as amObject as an argument to dir function. You can see the output, how it has listed the attributes and methods available for area module. Let's see an example. To calculate the area of the circle only, can be done using the from statement, along with the name of the submodule to be called specifically. The left-hand side code is the modification of right-side code, area.py. Here, we are modifying using from statement along with the name of the submodule to be called specifically. The syntax is from module_name import function_names is used to import a particular attribute, subroutine, from a module. In case you do not want whole of the module to be imported, then you can use from module_name import function_name statement as we have done in this example. Look at the left-hand side code. In order to calculate area of the circle, circle_area, function is being called from module area. Note that, for modules having a large number of functions, it is recommended to use from instead of import. Point 4. Importing a module using from module name import star. This statement allows a user to import everything from the specified module. This construct will import all Python definitions into the namespace of another module. However, the use of this construct is not recommended much as it may result in namespace pollution. We may have several objects of the same name and the definitions can be overridden. Let's see an example. Import star gives access to all functions in area module. You can use all the functions in area module directly. From the previous examples, we have observed that import statement in Python can be represented in any of the following for importing module in some other program. Let's recall. Point 1. Import test. Imports the module test and creates a reference to that module in the current calling program, or namespace. After executing this statement, you can use test.name to refer to the objects defined in module test. Point 2. Import test1, test2, test3. This statement shall import 3 modules, namely test1, test2 and test3 in current namespace. As a result, all the definitions of these modules are available and can be used as module_name, name. Name represents the submodule or any object. Point 3. From test import star. When you use import start statement, it shall import all the submodules or objects defined in the module test into the current namespace. So, after executing this statement, you are required to simply give the name of the object to be referred to, defined in the module test. In other words, name would now be used as name only, without specifying module's name, that is, test.name is not required to be given. If name was already defined, it is replaced by the new version, the one imported from the module. Point 4. From test import T1, T2, T3. This statement shall import the module test and create references in the current namespace to the given objects. In other words, you can now use T1, T2, and T3 in your program without specifying their module's name along with them. Note: whenever we are using a module in our program, for that module, its compiled file will be generated and stored in the hard disk permanently. Let's discuss about the name resolution, resolving scope of a name. Python name. A Python name is an identifier, that is something we use to access a Python object. And, in Python everything is an object. A name can hold any kind of value. Namespace is a collection of names. It maps names to corresponding objects. When different namespaces contain objects with the same names, this avoids any name collisions. Internally, a namespace is implemented as a Python dictionary. When Python interpreter starts up, the namespace containing the built-in names is created and is never deleted until the interpreter quits. We have three namespaces. Local namespace. Local namespaces are created whenever a function is called, and they hold the names of variables defined inside that function. These names are only accessible within the function's scope. Next is global namespace. The global namespace is associated with the main module or the module at the top level of the program. It contains names defined at the top level of a script or a module. These names can be accessed throughout the module. However, to modify them inside a function, you must explicitly declare them as global using the global keyword. And the last one is a built-in namespace. This namespace contains all the names of Python's built-in functions, keywords, and exceptions. These names are available by default and do not require any explicit import. Examples include print, len, input, etc. Python resolves the scope of a name using LEGB rule, that is, it checks environments in the order local, enclosing, global, and built-in. For every name reference, Python does the following to resolve it. Step 1. It checks within its local environment, LEGB, or local namespace, if it has a variable with the same name. If yes, Python uses its value. If not, then it moves to step 2. In step 2, Python now checks the enclosing environment, LEGB, if there is a variable with the same name. If yes, Python uses its value. If not, then it moves to step 3. In step 3, Python now checks the global environment, LEGB. If there is a variable with the same name, if yes, Python uses its value. If not, then it moves to step 4. In step 4, Python now checks the built-in environment, LEGB. If there is a variable with the same name, if yes, Python uses its value. If not, Python would generate the error. Name variable is not defined. Thus, LEGB rule means checking in the order of local, enclosing, global, built-in environments, namespaces, to resolve a name reference. Let's learn about module aliasing. Module aliasing in Python refers to the practice of giving a shorter or more convenient name, alias, to a module when importing it. This can be helpful when working with modules with long or complex names, or when there is a possibility of name conflicts. It allows you to use a shorter name to refer to the module's contents without affecting its actual name in the Python standard library or file system. Module aliasing is achieved using the import statement. Syntax is import module_name as alias_name. Here's an example of importing the math module and giving it an alias m. In this example, we can use m instead of math to access the functions and constants provided by the math module. Similarly, you can also use aliasing when importing specific items from a module using the from module_name import item_name as alias, which is the syntax. In this example, square_root is an alias for the sqrt function from the math module. Remember that while aliasing can improve code readability, it is essential to use meaningful aliases that convey the purpose of the module or item being imported. Overusing very short or cryptic aliases may make the code harder to understand for others and yourself in the future. Thanks for watching. Watch the upcoming videos. Using Python Libraries Part 2. Package and library, locating modules, Python standard library functions and modules, Python's built-in mathematical functions, Python's built-in string functions. You can check the link in the description box below.